So the reciprocal function is a parent graph that you should know. I'm going to plug in just a few values here for x. So this might be like, I'm just going to plug in -4, -2, -1, 0, 1, 2, 4. Just plug in a few values and see what happens. So if I plug in -4 there, I get for my y value, my f of x value, -1 over 4. So -4, -1/4, somewhere right in there-ish. This would be -1/2 when I plug in -2 there. So -2, -1/2, right about there. -1 over 1, which is -1, -1, -1. 0 is 1 divided by 0, which is undefined. So typically when we have an undefined value, it's either whole or an asymptote, and this one is going to be an asymptote. So there is, for this graph, there's an asymptote at x equals 0. And this would be 1 over 1. This, by the way, was -1 over -1, -1 over 0. Actually, that would be +1. Okay, so let's see, 1 over 1 is 1. So 1, 1. 1 over 2 is 1/2, so 1/2. 1 over 4, 1/4. You can probably see this graph is getting smaller, kind of approaching an asymptote in that direction. Same thing here. It's approaching an asymptote, and that asymptote will be at y equals 0. So there's two asymptotes for this graph. There's one at y equals 0. And I really think we need to plug in at least a couple more points here. So let's plug in like, let's do 1/2 and -1/2 at least. So if I plug in -1/2, that'd be, or 1/2, that'd be 1 divided by 1/2. Divided by a fraction is like multiplying by the reciprocal. So that's like 1 times 2, which is 2. So 1/2 comma 2, you can probably see this graph is also approaching the asymptote there at x equals 0. Plug in -1/2, that's 1 over -1/2. So that ends up being -2. So -1/2, -2, right about here. And again, this is approaching the asymptote right there, the vertical asymptote. So your basic sketch of the graph looks like that. You don't have to memorize all these points. If I ask you to graph f of x equals 1 over x, here's what I might expect. If you have graph, you basically say, okay, I've got an asymptote at y equals 0. So you have to have asymptote graph if you want to sketch this out. You have to have an asymptote also at x equals 0. So x equals 0. And the basic behavior of the graph, it looks kind of like this in the first quadrant and like this in the third quadrant. And that would be a good sketch of the graph. If I just ask you to sketch it, that's what I would expect for full credit. I'm not expecting you to graph every single point like we have here. Okay, so we're going to graph both these graphs on TI-Nspire and see what they look like. So if we graph, let's see, 1 divided by x, kind of like we just drew, it's got asymptotes there. You can see it has that same behavior. So it's 1 over x. If I hit tab and graph 9 over x, I want you to see the difference in the two graphs. They look pretty similar as far as their behavior. They both have asymptotes at the same spots. They're in the same quadrants. If I even did another one here, so if I did like 5 over x, it'd probably be somewhere in between those two. So you can see these graphs all have a similar behavior. They're in the same quadrants. They approach the same asymptotes. They don't go through any of the same points exactly. So what transformation is this? You may be familiar with that. Usually we have this, like when you have a number in front. This is not exactly a number in front, although I could write it like that, 9 times 1 over x. If you think of 1 over x as the function, and a number like 9 is in front of it, whereas in this one, 1 is in front of the function. So anytime you have a number bigger than 1, it's going to vertically stretch the function. So that's what's happening here, is you're vertically stretching the y values of this function. So that's called a vertical stretch. If you had a number in front that was like 1/2, that would vertically shrink it. How could this graph shift 2 units to the left? So let's try to adjust this equation and maybe make it shift to the left. So we know what 1 over x looks like. So I'm just going to, I don't know, maybe subtract 2 here and see what it does to the function. It looks like that moved it down 2 units. So that didn't do it. Maybe if I put plus 2 after the function, now that looks like it moved it up 2 units from where it normally is. So maybe if I put plus 2 here, that moves it from its normal spot to the left 2 units, but I want to move it to the right. So kind of like we have with other transformations, inside the parentheses here is what I would consider that x minus 2. That should move it to the right 2 units. So now we actually have an asymptote at x equals 2. So there's like a vertical line. I could almost, I could probably draw that in there. Let's see. I do relation x equals 2. You can see there's like an asymptote right there. I'm just going to change the attributes to make it, whoops. So there's an asymptote now at x equals 2 when you move it to the right 2. There's still an asymptote at y equals 0. So moving it to the right did not change the horizontal asymptote, only the vertical asymptote there. And so that's how you would move it to the right. If you want to move it 3 units up, well, we just had a situation like that. In fact, I could take this function as it is. If I just add 3 after the function, it's going to move it up 3 units. So now the horizontal asymptote, I think, would be at y equals 3 here. And so you'd have a horizontal asymptote at y equals 3. So we have these asymptotes now and our graph. So let's look at what the general equation of this graph would be here. So our general equation, I would write it down there, is f of x equals a over x minus h plus k. So a could stretch or shrink the value, depending on what it is. H is going to move it right or left. K is going to move it up or down. And I guess there's one more thing I wanted to mention before we get into this example here. And so let's see what happens when we put a negative in front of that function, or maybe just attached to, maybe a is negative there. So negative 1 over x. So instead of being in the first and third quadrants, everything's going to reflect over the x-axis, and now you're in the second and fourth quadrant. So a similar graph, asymptotes remain the same, but that negative is going to change the quadrants, in this case, if it hasn't been transformed, that your graphs are in. Okay, so let's try to do an example and see if we can graph this one from scratch. So what I like to do is graph the asymptotes first. So it's good to identify kind of what transformation is happening. So when you see inside the parentheses there that it says minus 4, that's going to go to the right 4 units. So my asymptote is going to be at 1, 2, 3, 4. So x equals 4. I'm going to draw and label the asymptote, x equals 4. And then this is going to move, minus 2 is going to move everything down 2 units. So it was at y equals 0. So now there's going to be an asymptote at y equals negative 2. And of course, this is just going to stretch it. Well, stretch it. The 3 is going to stretch it. And then the negative is going to reflect it over the axis. So normally you might think the function might look kind of up and to the right and down and to the left, but I think it's going to kind of move this way. I like to find the intercepts here. So I think a good step here, and it should really help us to find at least the x and y intercepts here. So to find the y-intercept, just plug in x equals 0. So y equals negative 3 over 0 minus 4 minus 2. So if we simplify that, that would be 3/4 minus 2, 3/4 minus 2, which is 3/4 minus 6, or 3/4 minus 8/4 is negative 5/4. So there's a y-intercept right about there, negative 5/4. And if I solve this solve for y, so let me kind of erase this a little bit. Okay, so let's say set 0 equal to y here. So we have -3 over x minus 4 minus 2. So I'm going to add 2 to both sides. I get 2 equals -3 over x minus 4. I multiply both sides by x minus 4. I get 2x minus 8 equals -3. 2x equals, let's see, 5. And x equals 5/2, or 2.5. So right about 2.5. There's an intercept right there. And so you can see pretty easily, hopefully, that this will be right about there. It goes through both intercepts. Again, it's got to approach the asymptotes. It kind of stays within that quadrant. If you think of the quadrant being the asymptotes kind of being your new axis there almost. And then, of course, instead of being first and third quadrant, it's kind of like bottom right here. So it's going to approach this asymptote here and kind of look like that. I'm not worried about individual points. Just want the behavior right. I like to get the intercepts correct. The asymptotes have to be labeled with an equation and dotted and drawn there. And that's a really nice graph. Let's try another one. Again, I always do the asymptotes first. So let's figure out which direction this is going. And start graphing that. So this is going to go 2 to the left. So I'm going to have a vertical asymptote at x equals -2. So you want to label that x equals -2. Now a horizontal asymptote is going to move up. So y equals 1 is the equation of that. This is vertically stretching it. I really want to find the x and y intercepts. So y equals 4 over 0 plus 2 plus 1. That would be 4 over 2 is 2. 2 plus 1 is 3. So y equals 3. So 1, 2, 3, right about there. And if I find the x-intercept, so that would be 0 equals 4 over x plus 2 plus 1. So I'm going to subtract 1. I get -1 equals 4 over x plus 2. Multiply both sides by x plus 2. I get -x minus 2 equals 4. Add 2, you get -x equals 6. And then x equals -6. So x is -6. 1, 2, 3, 4, 5, 6, right about there. And so the graph is going to go through that point, but kind of stay within those asymptotes. And same thing over here, it's going to go through this point, but stay within these asymptotes to approach both asymptotes. And that's a pretty good sketch of the graph. That's really what you need. So graph the asymptotes first. So first, graph the asymptotes. Second, graph the intercepts. And the third, just sketch the graph. So I just need a sketch there. Make sure when you do the asymptotes, you label them with your equation. Here now we're going in reverse. Make sure you're kind of getting the concept. It's not a bad idea to just write the general equation here. So y equals a over x minus h plus k. So that's kind of the general equation here. It looks like this has moved, let's see, 3 units to the left. So it moved 3 units to the left. And it looks like it kind of moved 2 units down. So it went 2 units down. And so, and the quadrants there, it's still like in the normal kind of position, kind of like a first and third quadrant type of position if this were not transformed. And so, A, well, actually it says A is 2, right? So, well, that's nice. I didn't really know exactly what the A value was, but now I do. It's going to be 2. This is going to be X. You have to think about it. It's going to be plus or minus. I want to move to the left. So X plus 3. And then, not plus 2, there would be minus 2 there. So minus 2, and that would be your equation of the graph there. One more quick problem. If you've got something like this, we've got y equals, says the absolute value of a is 2. You can tell that a is negative because of the quadrants it's in here, so I'm going to say it's -2 is a. It looks like it has moved 1 unit to the right, so this is going to be x minus 1. Looks like it's moved 3 units up, so plus 3, and I think we have our equation. I know it went quick, but time's